beyond that creation of 2D arrays. Beyond that 1D array, we are going to see today how you can create 2D dynamic arrays also using the pointers. And before that, I'm going to talk about pointers and functions. So I'm going to share my screen now. Okay, so pointers and functions. So in what ways we can pass arguments to a function? By value, by reference, and then the third thing is that by pointer also. Okay, so now in case we are passing by reference, then is it going to modify the variables in the calling program? Yes or no?
Yes, sir.
Yes, sir.
Yes. And if it is
Yes,
passed by
sir.
value, then it
No
No,
is
sir.
copied
No.
and
modification is there.
No, sir.
it did not
And
modify the variables in the calling program. Okay. So in this case, either a reference argument or a pointer can be used. If you want to change those, modify those variables, so either you have to do pass by reference or a pointer can also be used. Till date, you have studied about pass by reference. So let us see what is there in the pointer, like passing pointer in the function. So it will also be behaving like pass by reference only, but you can see what is the syntax and how it works. So passing to a function by reference using pointers. Okay, let us see that. In this example, you can very well see that how I am passing these parameters by reference or by value.
yes, by reference.
By
By
reference.
Ampersand
reference.
is there, and in the you will remember that in the prototype I can omit the name of the variable. Okay.
Variable.
Yes. Now look at this where I'm calling this. It's a void type, so I can call it as a standalone function also, and I'm passing to actual parameters x and y. These are integers. So here also it is integer. Now I'm passing them as by reference. So when I write the definition of this function, whose prototype is mentioned in the beginning, so definition is in the end of the program, then you can see int ampersand and some variable name has been given. Int ampersand has been used. So this when I say int ampersand variable var1, so what it is? It's a reference variable
Yes, sir.
of which
Yes, sir.
variable?
X,
X.
X.
sir.
X is going to be assigned to this. So they X and var1 are
Very.
alias.
Yes.
They are referring to same address, but different names are there. Var1 or X. They are referring to the same address. Reference is same. Now inside this you can see var1 asterisk equal to 2. What does it mean? Var1 is equal to var1 into 2. Okay, so some changes are happening to var1 over here also. Now there is no return, it's a void type. So when I call this function, you can see over here, you must have made so many programs in the tut also related to this pass by reference, but it's for the sake of all that I'm again telling you this thing. Now, if you see out after calling this function, so what do you get? Whatever changes had taken place inside this function are also available after calling of this program xy. So I get the changed value as per the definition of this function. In this case, it is void twice. Okay, void twice this. So pass by reference is okay. Yes, it's a quick recap for you, many of you. Now, same program here. I'm just putting the name of this. In the previous program, I had omitted. It works. It works, and I can keep the same name of also, so that you don't get confused. Same name. Now I get the same result over here. Now I'm trying to pass this pointers. Looking at the prototype of this function, you can see that pointers are being passed. Yes or no?
Yes, sir.
I'm
Yes.
not
Yes,
using
sir.
Yes.
ampersand. I'm using asterisk over here. Now look at the definition also. Int It's a pointer. It's a pointer, right? So these variables have been declared over here. Int x equal to 2, int y is equal to 5. Now I'm calling this function over here. Now since I'm passing, I have to pass a passing pointers over here as an argument. So in the actual argument, what should I write? X comma y or ampersand x comma ampersand y? Why I'm writing like this?
Because we are passing the address to pointers.
For address.
PTRX, this address will be assigned to it. This address will be assigned to it, isn't it? Yes. Now look at the definition inside the body of this function. Asterisk PTRX. What it means, asterisk PTRX? Dereference.
Value of x.
Okay, then is equal to asterisk PTRX into 2. So whatever value was here, so asterisk PTRX will be dereference. Value of x will be there with it, and then it is multiplying by 2 as per this, and then the new value will be assigned to which variable using this dereferenced pointer. X. Similarly to y. So when after calling of this function is over here, so what values will be printed? X and y.
4 and
The
10.
original values 2 and 5 or the changed values?
4 and 10.
Changed values.
Changed value. Why? Why the changed value? I did not change any value.
Pointers are passed by reference.
Because we pass the address of that variables.
Address of that variable, and I'm dereferencing that pointer and then assigning a new value to it. So whatever new value is assigned to this dereference thing will also be changing the variable to which this pointer was pointing. So PTRX was pointing to x and PTRY was pointing to y. So dereference thing, you assign some new value to it. So x and y will also get changed. Any doubt about it? Everybody agrees to it?
Yes, sir.
Okay.
सर हाँ ये वैल्यूज डबल क्यों हो गई सर? एड्रेस पास किया था ना हमने तो.
Can you explain it once more?
Yes. We had passed address. We have passed address. So if I say C inside this PTRX, C out PTRX, what I'm going to get? The address of
X.
And
Yes, sir.
PTRY would be holding the address
Y.
of Y. Now inside this you can see, can I use this asterisk PTRX inside this function or not?
Yes, sir.
Yes, it's local to this, I can use it. So when I simply write C out asterisk PTRX, what value will be printed inside this function? Should I do it? I have the program with me. I can show you that also live. First tell me, then I will show you.
Yes, sir.
Before this, over here, if I say C out asterisk PTRX, so what will be printed?
Sir, x की value will be
2.
sir, value of
Yes.
2.
2 will be printed. Now if I change that value, through this compound assignment, I'm changing the value of dereference PTRX. If I assign some new value to asterisk PTRX, so will it not change the value of x?
It will change.
Yes, sir. It will change.
Let me show you this one. This is the program. Okay. Now just to prove it, I'm going to out x. Why I'm doing it? Y. Okay. Or I should do the handle also. Now, if I print the address of x and y, and inside this function also, if I try to ptrx ptry, will they be same?
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
No,
Yes,
sir.
sir.
Yes.
They will be same.
Somebody is having doubt. You can see address. This address was there. Now this function was called, so that definition got executed. Now it is cout ptrx, same, because I'm passing the address to this pointer. Pointer is being passed, and this ampersand x is assigned to ptrx, ptry. That is why I'm getting this. Now you tell me, if I say cout x, okay, or I can write in one line also. What will be printed?
Sir, 2 and 5.
2 and 4, 5.
2 and 5. Good. Now, because of this, which value I'm changing?
X and Y.
Hmm?
You're
X and
changing,
Y.
sir, X and Y.
Okay. Suppose now I print X and Y. What will be printed?
Sir, error, sir.
Error, sir. Yes, sir.
Error.
Because they are not local
Scope
for
meaning
that function.
They are
not
not
local.
Sir, error.
It will give me error. So I can't use this inside this function to change it? X and Y?
Yes, sir. You
Can I use
can't.
x equal to asterisk equal to 2, or x
No,
equal
sir.
to x into 2? Can I
No,
use
sir.
this?
No, sir.
No, sir.
No, sir.
No.
Then how should I change the value of x and y? I can use this
Sir, dereference the pointer.
dereference thing.
Dereferencing.
Now you got it? Okay, you can see x and y address and ptrx and ptry same. Now if I say dereference ptrx, it gives me x, and dereference ptry, it gives me the value of y over here. Now since they are same, so if I use this line number 28, am I not changing x and y?
Yes, sir. You are changing.
Yes. So it is changed. And then when I come out, I get the new value, x change value over here. Got it?
Yes, sir.
Yes, sir.
Cout, line number 16, I'm getting
Yes,
this.
sir.
Okay, so you can pass pointers, okay, and they'll be passed as reference only, because we get the same effect as pass by reference. It's not getting copied. So the same thing which I have just now explained is explained in this slide also. Okay. You could take the same name. It doesn't matter. Sometimes you ask that if we take the same name, what happens? It doesn't matter. You take the same name and you get the same thing. Okay. Why this x and y are possible inside this now?
Because
Local to this function.
the variables of this function.
Yes, and it's a pointer local to this function. Okay. Now you know that sometime I showed you this example also for swapping. So you can use the pointer also to swap the values. So how it is happening inside this? Instead of that values x and y, ampersand x and ampersand y, so I'm using the same concept of dereferencing this pointer and then swapping the values. Do you have any doubt about this? Should I explain it again?
Sir,
Yes.
so instead of asterisk PA, we could have used any other value like direct X could be used. So which would have given same answer, sir?
Let me see. This is the program. So just
Yes,
suggest
sir.
change what you are suggesting. There should not be doubt.
Sir, remove all asterisk PA and all, sir, all of them, and put a X on instead of that.
Yeah, sir. They will run because they will be local for that function.
What should I write? X and
Yes,
Y.
sir. Why?
Then I have to remove from here also, isn't it?
Yes, sir.
Then
No, sir. Sir, from below also. Asterisk
what?
PA to X.
Okay, I will do it, whatever you're suggesting.
Sir, then line 13 will give error.
Ampersand is also removed.
No, this doubt should not be there.
Yes, sir.
Because,
We can't store address in any
It will
common
be passed
Yes,
by
sir.
value.
no, what you're trying to do is float temp is required or not?
Yes, sir. Required.
Required.
But then how will that change reflect in the main?
I want to
It will
show
be
that
passed by
also.
value.
So
It
that
will not reflect, no, if we don't do pass by pointer.
okay, instead of P, I'm
By
writing
value.
X.
Yes, sir.
No, let me do it so that doubt is clear. So
Yes, sir.
now what should I do? X equal to
Y.
Y. Done.
Y is equals to temp.
Y is equal to
Temp.
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 You're suggesting this? Somebody suggested to do
Yes.
this?
Yes, sir. Yes,
Okay.
sir.
Now you tell me this will happen. But when okay, I have to remove this ampersand also. You have entirely changed the program. When I see out after swapping, what values will be printed?
Sir,
Same
can
value.
you,
Function, this thing has
sir,
happened.
can you?
And if I see out, then I will get the changed value inside this function. If I
No,
see
sir.
out, yes,
Sir,
tell.
sir, add a ampersand after, sir, in the function call. Sir,
That is
but
what I'm
yes,
saying. We have done the same thing using the ampersand using pass by reference. That is what I'm saying. You
yes,
can
sir.
do it by pass by reference, and you can do the same thing. The effect of this passing the pointer is same. Are you getting my point?
Yes, sir.
Will it show? I will just compile it and then.
No, sir, it will be wrong.
A contains 11. It has not swapped. Why it is not swapped?
Because the sir
Pass by
values are
value.
only
You have
computed.
done. You have learned this part. You have very well learned this part. Here I am not writing any ampersand. Okay. Here I have to write as per the prototype or the definition. I have to make it pass by reference. Now it will work. Now after calling
Yes,
this
sir.
function, it's going to show me the changed value. Now you can see A contains 15 and B contains 11. It's not
Sir, if
merely
we-
that I just see out the change value. No, it should get changed. The variable should be holding that value, storing the change value. Then I can say that the swapping has taken place. But see, slowly, instead of this, I am writing this. Now I am, instead of passing by reference, I want to pass as pointer. Can you see the difference? Now Can I use this kind of thing over here?
No, sir. Asterisk is also used.
Asterisk.
Yes.
Just tell me why I'm writing asterisk.
X and Y are pointers.
So dereferencing.
Dereferencing.
Yeah, dereference to change the value to value store.
So not to get confused, I am writing like this. Okay.
So
Also
the
in
address
random
cannot be exchanged.
You can exchange. How?
So if we don't dereference it, then the addresses would be exchanged, no?
You can try with that method also, exchanging the address and then see what happens. But how you are going to change the value even if you change the address? Dereferencing will be required, no?
Yes, sir.
Or how you are going to
Without
print?
changing the asterisk, we can, I think, change the exchange the address also.
Okay, you can try, but I'll find it easy to understand this way. Okay, now let me show you. So what is the mistake in this program? I have done everything, changed everything over here.
%A and %B in
Why
line
it is
13.
required? Why it is
Swap
Address to store address in point.
To assign the address to the
Yeah,
pointer.
if I say AB, then this PTRX would require the address. And I'm just giving it some value, which it will not take. Let me just remove it and then compile it. Didn't give me any error. So on its own, it has taken. It seems like this. Good, intelligent. But I will always mention this, so there is no confusion. Okay. So I will be writing this. I am passing the address, and then rest of the things are done like this. Any more query about it? So you can pass pointers.
Sir, if we declare the temp also as a pointer and then write without that asterisk, then it will run.
Yeah, you can. Then what you are going to do?
And sir, this asterisk we will remove in the 27, 28 and 29.
Like this, like this. Okay. That is what some people were suggesting. It didn't work. Why it didn't work?
Sir, you
The
didn't
address
change
are
in the
changed,
function.
sir.
Are going to be changed by this.
Then how the values of X and A and B will change?
We have to dereference it.
But we are not returning anything. Temp will remain inside it. PTRX will also remain inside it. Are we returning it?
No.
So it remains inside this. So inside this, when I do this dereferencing, then as soon as this dereferencing takes place, the value of X and Y will get changed.
See out inside the void function, then will it work?
Sir,
if we put a see out inside the void function,
then it will just be simply printing it.
So sir, then the values will be swapped or not?
Not swapped.
Okay.
So if we
If
like
we
it
get
won't be
swapped,
swapped.
then it would have shown me here itself. Okay.
Why aren't the values getting swapped if you are like interchanging the addresses?
Not getting changed. Yes.
But the address would be changed, right?
And how address is getting changed? But
Sir, can you do cout in the main function for address
see what
before
is the
and after?
difference between A and B and these addresses? This PTRX is now holding the address of which variable?
A.
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 And PTRY is holding the address of which variable?
B.
B. But these are the pointers which are pointing towards, instead of PTRX pointing towards A, it is pointing towards B. That's it. But how do I show the value of A and B? How I should show?
The dereference PTRX.
Then only I will.
Yes, sir.
I can show, but did I change the value of X and Y?
No, sir.
After swapping 40 and 20, yeah, it's showing like that only. So inside also you can see what it's showing, interchange value. Let me just make it better. Okay, this is inside the function. Then when the function call is over, it's showing after this
comma
semicolon. Yes. Right.
Sir.
Like 88, 99. Yes.
Sir.
Now tell me.
Sir, when
Inside it's just showing me that okay, if I dereference it, then it's giving me value. But what about over here?
No, sir. Sir, asterisk PTRX is pointing towards A. So, sir, why when we are printing A means we are passing by reference. So, why A is not giving the value, swapped value?
Could you print the address of A and B in the main function before and after swapping?
Sir, if the inside the function the value of asterisk PTRX and PTRY is interchanged, then why the value of A and B is not interchanged? Because we are passing by reference.
A and B are not interchanged because I have to use this dereference thing as L value to assign a new value to that variable. If I dereference it, I can get it. And can I use this dereference thing outside this? After calling this function, can I use this asterisk PTRY, asterisk PTRX and asterisk? If I am able to use it, then I will get the value. So that is why it was used this way, using the dereference thing. Not
but the value of A is equal to asterisk PTRX, na?
If it is not part of the function, if you are using it in the main, all these things, then it will work. Then it will show you. As soon as you do asterisk PTR and all that, it will show you.
So could you do that what Shreyas asked to print the values of addresses before and after swap?
%A %B, okay, and then over here you want me to print the address after function call is over. Okay.
Sir, also in the void function, the swap function.
Okay. A and B are available. This is not
So
available.
declaring A and B in void function.
So addresses of PTR
Why,
X and PTR Y.
I should declare it inside this? Address would be PTRX,
PTRX and PTRY.
PTRX, and PTRY. Okay. So the first set of address was 6FFE08 and 6FFE0C. Now, after swapping, after this swapping, this was the address. Now, these are the swapped values which are getting printed because of this. And after swapping, this is the address has swapped. Now, inside the function, the address is swapped. But what about this? These are local to this function, no? PTRX and all that. Inside this job is done, but what about A and B?
So sir, A and B and A and B will always stick to their original addresses. Like they would retrieve those sir, whatever happens in the function, it won't affect what A and B will finally take. So like they will always keep waiting for their original addresses which they passed, even though they are swapped in the function.
It looks like that, but you have to change the value of with reference, pass by reference. It was easy, but here it is pointer. So you are passing the addresses of A and B into these pointers, and then you are dereferencing them. As soon as you dereference and assign a new value, so immediately it will change the X and Y value also. If you are using this kind of thing. So once the value gets changed in the memory, so after calling this function, these new values are also available. So this is how it is working.
Sir, in the main function, sir, when we are printing the %A and %B after swapping, then the addresses are swapped. So sir, why the value of A and B are not swapped? Means now the address which A was having is now of B, and what B is having is now of A. Means if I am having a house and you are having a house, if our addresses change, then in my address you will be living, and in your address I will be living. So sir, how A and B are not changing the values?
So you change it on paper. Theoretically, you have changed inside this function, but how it is not reflecting outside this function. You change it in your just sitting on the table. You change that. Okay, this is your address. This is my address, but physically it was not changed. There was no effect of it. These are local, na?
Okay, sir. Okay.
Okay. So that is why we were using all these things. If you try, you can change this thing. Don't instead of making this function, you take this kind of thing within the main and then see the effect of it. Okay, I will leave this as an exercise to you.
Yes, sir.
You got my point, what I'm saying? Instead of this, these are local to this. Instead of doing all these things, you do it in the main. Right. So you have seen that we can pass pointers in the functions also. there is another example, passing arrays in pointer notation. We know how to write the arrays in pointer notation. You know?
Array name is the name of address.
Yes, I'm calling this twice. I array is there. 5 elements are there, and I'm saying twice. Why I'm not writing ampersand over here?
It is also
Because
an
Arrays
address.
are
Array name is the
Address.
address.
So I need not write that ampersand thing. And if I write in my definition this twice int asterisk, what I want to do, I just want to double these values. Each element should get double. I want to show the multiplied by 2. So if I write something like this, int asterisk ptr ptr is a pointer. Okay. So why I'm taking int over here? Because I wanted to pass this constant
Integer
pointer I array, the address over here. Okay, done. This array has been passed. Now inside this I'm using a for loop. So array size was a global variable, so I can use this in the for loop within this function also. And I'm writing this ptr array plus plus and dereferencing star equal to 2. So what will happen? It will dereference, double the value, then the first, where this ptr array will be pointing first initially.
First element of the array.
The first
First
element.
element of
So what?
First element of the array.
Which address you passed? I array. I array means address of the first element. So address of the first element, dereference it, double it. Okay, change the value. You can see now I'm again using this dereference thing. Change the value. Okay, it got changed, modified. Yes. Then for loop, again for loop.
Sir, why we
Will
are
this
using
ptr
plus?
ptr plus plus? Why I'm taking this ptr plus plus? How I am going to store the address of the next element in it? After changing it first time, dereference and then change it. So it will change asterisk ptr array is equal to, suppose is equal to asterisk equal to 2. So what it is going to give me?
Sir, array is a contiguous, so it will go to the next address.
No, first, suppose I'm talking about just first element. So asterisk ptr array is equal to asterisk ptr array into 2.
Yes, sir.
So what it is going to give me?
Double the value.
Double the value of the
double of
first element.
First element, yes, sir.
Now over here, order of precedence is there, so it will also increment. Now after this execution of this evaluation of this expression, after doubling the first thing, in this way it will be storing the address. Ptr array will be storing the address of next time
Second, yes, sir,
second element.
second element.
So
We can write it on the second line as ptr plus plus.
you can do it, and then you have to curly braces and all that. You can see.
Sir,
how
if we don't use the plus plus, then in all time it will show me 2020.
Yes. Let me see. Yes, yes. Pointer, array pointers, no, swapping. I need to check which, no, there are certain. Yes. What you want to do?
So remove the plus plus and then compile and run.
You tell me what is going to happen.
I think, sir, all values will be 2020. Sorry, 22.
So first value will be doubled
No,
5
sir,
times.
only first value
Yes,
will change.
first.
Yes.
No, it will times double, 5 times double, because the for loop will be
Yes.
going.
And rest of them will remain same. Okay.
Okay, sir.
And if I take, instead of this, if I take this, what is going to happen?
The
Yes,
first
first
value will
element
not
will
be
be not
doubled, all
doubled.
others doubled.
First will remain same.
first will not be tested.
Hmm?
Oh, one.
You are changing, sir, only the dereferenced value, not the pointer's value.
Nor the pointer, exactly. So if I say ptr plus plus, then it is moving the pointer also. Okay. Then the pointer will be, next time the pointer will be pointing towards the next element. Okay.
4 times हो जाएंगे सर.
नहीं अभी तो, now it will be okay. Now it will be okay. इसको बंद, I should close this.
Yes, sir.
That is how you are getting the result. Okay. So if I, instead of this, if I take this, so what is the interpretation of this? In fact, it is working something like this. First PTR, it will be incremented, it will be holding the address of the second element, but when I dereference it, at that time it will take the previous address and then dereference it, and that will be holding this doubled. So next time it will move to the next element and then dereference the previous thing and then double it. Like that it will work.
Sir, in the bracket, if you write plus plus before the PTR, sir, not the post.
Syntactically it is correct.
Yes, sir. The first the value is get
Here plus
incremented.
plus only is going to move it, huh?
Okay, sir.
This way also you are getting something. I'm keeping it intact like this. Okay. Okay, now I move on to the new thing. What it is, let me see. Pointer to functions. I just want to introduce this thing. What it is? Or function pointers. So like array name, function name is actually a constant pointer. That is also a constant pointer. So if I want to declare a pointer to a function, what does it, how it is helpful to us? You may visualize that value of a pointer as the address of the code. So when you write the function, some code is written. Okay. When I'm calling that function, it refers to that code and then executes as per the definition of that function. So that code, that definition, suppose in this example, you can see, in this example, you can see, this is the definition of the function. Line number 20 to 29. So this is the code. So this code is also lying in the memory. It's being stored in the memory. So by the name of this function, I can get the address of this function, where from which location this code is starting. Okay. When you were writing the name of the array, so you were getting the address of which element?
First element.
First element. Now by the name of this, if I simply write C out twice, let me do it somewhere. Function definition, can I do it here? I'm not sure. C out less than twice. Something I'm getting over here. So that gives me the name of that function will give me the address of this function. Name of the function will give me the address of this function. So what is the address of this function? From where this code is starting in the memory. Okay, yes. Now we can move forward. So pointer to a function is a pointer whose value is the address of the name. Okay. Now how to declare it? First, let me show you just to visualize it. This code is lying in the memory and the address is name of the function gives me the address where this code is lying. Now, can I use this function name? Name can be used to store the address of this function. Yes or no?
No, sir.
No. This is stored in memory, this code of the function. Yes. And
Yes,
name
sir.
of the function gives me the address of this, from which location this code is stored in the memory. F gives me the address of this function.
Yes, sir.
Suppose you have a big house. I mean, you have 50 rooms, 20 rooms, 50 rooms like that. So it is starting from which location to which location it keeps on going it. So the name of your house, like you give me some name of your house. Okay. Can you give me some name?
Pile house.
Huh?
Pile house.
Which house?
Pile house.
Pile
Name of a house, sir. In my
name of the house. So that house, that villa is starting from some x coordinates going to y coordinates, length and breadth. So
yes, sir.
In the beginning only I know the pile house name is there, name of that house is there, so I know the starting address of it. That's it. So if I declare a pointer, can I store this address or not? Pointer job is to store the address.
Yes, sir.
So I can store this address. But
Yes,
how
sir.
to declare the pointer for a function, pointer to a function that it can store the address of this function? It's not, it's similar to the way we did, but it's not same. So now our job is that we know that this function is having some address. All the functions will be having some address. Now we want to store this address into a pointer. So the pointer which will be storing the address of this function will be known as function pointer or pointer to a function. Now next thing is that how do we declare that pointer which will be storing the address of the function? Is aim clear to you? Objective is clear? Yes or no?
Yes, sir.
Yes.
So the pointer is pointing towards the name of the function.
It is storing the address.
Storing
You
the
have to
address of the
visualize.
function.
It is storing the address of the, and name of the function gives me the address. So what is the address? It will be starting. This will be starting from some location in the memory.
Yes, sir.
Okay.
No, sir, I didn't understand that.
This is your house, villa.
Yes, sir.
It is there, and farmhouse is there for you, starting from some location.
Yes, sir.
1 kilometer long villa.
Yes,
Lot of jungle, lot of big swimming pool, everything is there inside this. This is a big house, farmhouse. Now, by the name of that farmhouse, the address is known to you. Now I want to store the address of this villa or the farmhouse into another variable. So what variable I can use to store the address?
Just another pointer.
Another pointer. Good.
Yes, sir.
Now declaring a pointer to a function is required, isn't it? So how do I declare a pointer to a function? That we have to learn. See. Okay. Now how do I declare it? I will tell you. Int f int. Suppose this is the prototype of the function. Then you want to write the pointer to this. What you will do? Whatever return type of this function was there, you have to mention that. And within parentheses, I will explain you this why I put this in parentheses, not without parentheses. In case of functions, within parentheses, you will put first thing is asterisk and the name of the pointer which you are going to give from your side. Okay. Then
yes, sir.
Again parentheses, whatever arguments were there, you will be mentioning over here also. Okay. How you are going to do? Just this is the function prototype. Now return type same. I am trying to declare over here int asterisk p. Pf is a pointer to a function whose definition was as per this prototype. Now int, okay, int within parentheses asterisk and f was the name of the function. So I'm giving a slightly different name of the pointer as pf. And whatever parameters were there, I am going to write over here also. So that declares function pointer pf. And it will be a pointer to which function?
F.
F.
Function.
Now, pointer has been declared, but I want to store address of what? What address I should store in PF?
Function.
Function. So I can either do ampersand F. Okay. That gives me the address of this function. Or I can simply write PF is equal to F. F simply the name of the function also gives me the address of that function. These things are clear to you or not?
Yes, sir. Clear.
Yes.
Sir, asterisk PF should be is equal to F.
Asterisk PF is equal to F. No, asterisk PF, so that will be dereferencing. Actually, when we declare int asterisk PF is equal to ampersand X, for example, int asterisk PF is equal to ampersand X. So, or in first line, I was declaring it as int asterisk PTR semicolon. Then in next line, I can write PTR is equal to ampersand X. If I write asterisk PTR is equal to ampersand X, will it make sense?
No, sir, I understood, sir. Leave it, sir.
Okay, okay.
So I want to ask whether that int x is needed there in declaring function pointer. That int x is needed. X.
X you can prototype your writing, so you can leave it.
But in function we didn't use that int f.
No, this is a prototype. This is a prototype.
Right, it's a prototype.
It's a prototype. I can just go to that. Pointer to, yeah, it is here. Okay. So this was the function. And then function definition is here, square int. I can quickly go through it. Then I can close. Just give me 2 minutes. I will again explain it next time also. Int this is the prototype. Now in the main, I could declare it here also. I am declaring it in the main. Now how do I declare the pointer to this function? Int, return type is int, parenthesis, asterisk pf, I give the name. I have to put this parenthesis. I will explain the difference also. Why don't we take this without parenthesis? Then I'm not using anything when I'm declaring this pointer to this function. Okay. Is it okay
Yes,
now?
sir. Yes, sir. It's okay.
Now
Yes, sir.
pf, this pointer has been declared, but what should I store in that? Address of this. At this time, at the moment, as of now, I am having only one function. If I had several functions, then whose pointer would have been similar, then I would have changed this address pointing towards another function, third function, fourth function. But here in this case, I am just having this, so I am storing the address of this square function. Okay, yes, done. Now come to this for loop. You know, you could very well find the square of these this 1, 2, 3, 4 kind of thing using s is sum
For loop.
plus this square I. You could pass that value, and then n over here is 4, so you could go up to 4, and then you could, using line number 17, you could easily get this kind of result. Yes or no? Using this function, yes. First tell me that quickly. Line number 17 is okay with you?
Yes, sir.
Suppose I block it and then run it. Okay. So I'm getting this result. How it is working? With the for loop, I was 1, so 1 was passed to it, squared, yes. Then it was in the s, 1 was stored, then s is equal to 1 plus this square I. Now 2 is passed, then 2 is also squared and added to it. So this is how you get 30. Now the same thing I want to achieve using this pointer to a function. Now how do I use this? Pointer is over here. It's dereferenced. Now pf, if I dereference it, it will be running the definition over here, and this value will be passed to it. Okay.
Yes, sir.
And
So
then I'm getting the
dereferencing
same
this-
result. I'm getting the same result.
So
Yes.
dereferencing PF is just as repeating the square definition.
Yes, yes, yes. Because it was holding this address of this. So
Address of
definition will
function.
come
Okay,
into
sir.
it. It will be calling that function, start calling that function. Okay.
Yes, sir.
So maybe we can close at this juncture, and then I'll take up in the next class more about it. Any doubt?
No, sir.